Okay, this is problem number 2 of homework number 7. Homework number 6, which is to be checked or due on the 7th of March. Now, uh, this was a previous exam problem, that's why there has some markings there. But in here, I'm giving you a plate like that. This end of it is clamped. There are circles here as these sizes, and then there's a point right in the middle that we would middle of this rectangle that we would like to apply a force of 100 pounds. Notice that it says do not use symmetry. Okay, so I want to do it exactly like it is, and I want to use shell elements obviously, and it says use quad elements only. In other words, use four-sided elements, so they have to go to advanced meshing tool. You have no other choice. And in there, make sure that the small hole is not meshed. This hole is not, sorry, this hole is ignored when it comes to meshing. And let's see now, what else do we have? We want local mesh refinement around the big hole. And okay, so what is the displacement of point C? Fine. Now, uh, because of the requirements that I have here, you have to do advanced machine tool. And this is going to be, I have done a couple of problems in class to tell you about that. So let's go ahead actually and create this. Let me start with the part file. So file, new, part, okay. Immediately save it, file, save management, save as. Let's go to homework number 6, problem number 2, which is right there. So we're going to create a geometry like that. On that plane, I'm going to sketch. The size of this rectangle is 10 inch by 5 inches. So let's make a centered one. It says do not use symmetry, so we're going to make the whole thing 10 inch by 5 inches. So this is 5, and this is 10. Okay. Now, I want to draw a circle here. We'll dimension it in just a minute. And another one on this side. Let's actually I'll give these dimensions. The radius of the big circle is 1, diameter 2, radius 1, and position of it is 3 inches from that left end. From here to here is 3 inches. Okay, good. And dimension of this one is radius 0.25, diameter 0.5. So this is radius 0.25. Okay, and the position of it is 3 inches from this other end. 3 inches. Okay, now because I want to draw a cutout here, a hole in there, so what I need to do is, there are many ways of doing this problem, but this is how I'm going to approach it. So I'm going to create a output profile, this one, and another output profile, that one, exit, okay. First I fill, oh, there's a point that I want here. We're going to do that in a minute. So we want to fill this thing. Okay, now I can split it with these output profiles. I could not have done it with those circles in the sketch, but I can do it now. Read it carefully. Element to cut is this. Cutting element is that profile. I'm not sure I could have, it could be that I could have done it at the same time with the other one. Let's actually check and see whether we can do it or not. Uh, Cutting element, can I do it with this? Oh no, the other side. Yeah, yeah, okay, I could have done it here. Good. Okay, let me hide this. Or you could have done it once again, repeated that once again. So let me hide this out profile, hide this, and hide the sketch out here. Good. Now I want to create a point there exactly at the center. So that obviously center is going to be 0, 0, 0. There, you can see it's kind of hard to see. If I hide this thing, you can see the point right there. Okay. Now, let's apply material properties to this. Let's make it out of steel, metal, steel on that part. Okay, save. All right, now we're going to go to generative structure and advanced meshing tools, because the kind of thing that you want to do has to be done in advanced meshing tool. First thing first, let us do this thing with uh, advanced surface mesher. Notice that there's two options here: regular surface mesher and advanced surface mesher. There are things you can do here that cannot be done in a surface mesher by itself. So I'm going to click on this thing, and it says, look at the bottom left hand side of the screen. It says select the geometry to be meshed. It's this thing. Now, if you click on the geometry, there is a box here which says what is the minimum hole size that you want to be meshed. So this is the diameter actually. Hole size is referring to diameter. Remember, this thing is diameter 0.5. So I can say that anything less than, let's say, uh, anything less than zero 0.7, any hole diameter, any diameter, any hole with diameter less than 0.7, just ignore it. Okay. So that's this. So in principle, it should be ignoring this because this is 0.5. We should be ignoring it. You say, okay, there's a couple of things you want to do. If you click, for example, on this icon, see this icon? See this icon right there? You click on it. We want to add a point. So we want to add a point as a constraint. So click on the point tab and go and select this point. In other words, include this as one of my meshed one of my nodes. Later on, I want to put a force here, for example. That's one option. And what else we have? So we say OK. And then we want, for example, a finer mesh around this hole. This one we don't have to worry about it because it's going to get ignored anyway. It's going to get, the mesh is going to go over it. But here is where you specify the imposed elements on particular edge, for example, around that edge and this edge on both sides. Number of elements, let's put it 20. How about that? 20. Okay. And I think okay. And then you zap it right here, zap it. I like to call this thing zapping, but it's really not zapping right there. It says meshed apart. You click on it. You see that? It went over that hole because this diameter was less than 0.7. It took 20 elements. I'm hoping it took 20 elements around that. We're going to find out because in all likelihood, well, actually, I don't know about that. It should have been 20, and it has this point included in your node, included as a node. So we say OK and exit. Okay, so let's see what kind of, I asked for 20 nodes around this, but let me see what happened here. Double click on it. It's not this one. It was, I, I expected to have 20 nodes, maybe 20 altogether. Let's check it out. Let me hide, let me hide this first of all. Not hide the part. Okay, good. So let me see. One. What kind of elements do we have here? Parabolic or linear? Okay, so 20. I asked for 20, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I think what happened is that I asked. Let me see. I just don't particularly like the way that 20 was handled because it doesn't look like it was handled properly. So this is okay. cancel that. Where is this? Let's go to this. Let's go to this advanced meshing tool. Okay, so I asked for 20 nodes around this, but it didn't do it. Let me see for a second. I'm not sure exactly what it put there. It did what I asked it, but it's not the number 20 that I do. So actually, you know what? Let's try it again. Let me deactivate this. Let me delete this mesh, delete it. Okay, let's bring this thing back. Good, let's try it again. So advanced surface mesher, this is the surface. Go over any hole of diameter less than 0.7, which means or go over that hole with diameter 0.5. And then I clicked on this, and as a point, I selected this point, and I'll include that. And the number of nodes around this. So let's try this thing. Mesh around a hole. Impose elements. Okay, hang in there, and I think it took the whole thing probably right there. It took the whole thing, and let's put down number of elements. How about just to dramatize the situation? Let's say 40. Apply. Should have been 40 nodes around here. I'm not going to count it, but believe me, it should be okay. Should be okay. Zap it. Yeah, I think last time that I selected both of these. I should have selected only one side. It would have selected the other side automatically, but I bet there are 40 nodes around this, which I'm not going to count. It went over that, and it included this node that I said I want to put a load on it later on. This was the point, right? Say okay, and exit. Good. So let's go ahead to our generative structure analysis. Good. So let's check out mesh. Right-click mesh visualization. There we are. The reason it didn't work the first time when I used the impose elements, I selected this edge and that edge. When I selected first edge, the whole thing was picked. When I selected the other edge, it deselected basically that boundary. But that's fine. So deactivate this plot. This end is clamped. And we are applying a force on that node. And that node, because it was included in the mesh, when I put a force on it, it will take it into account. So let's check it out. Let me see. Yeah. So deactivate that. Let's put a force, put a suppressor, force on that node. That node, this because I asked for this point to be included in the mesh. When you put a force on it, it will should actually take it into account and impose it on the node at that location. So what is it that I have here? 100 pounds minus 100 pounds. Remember, if you took symmetry into account, then we put half of that load there. And let's see, probably okay. So if this thing bends, means that actually, although I put it on the point, it is automatically transferred into that node because we asked that point to be included. So first of all, save this file, save management, analysis, save as in that folder. That's correct. All right, let's run it. If it bends, means that it actually took that into account. Oh, I forgot to specify the thickness. Click on this. What's the thickness of this 0.1? The problem description says 0.1. 0.1. Okay, when I say problem description, right here, thickness of 0.1 inch. Save it and run it. Yep. Notice that it did bend. And right there, this is where I applied the force. Remember that? And you can change the rendering to material shading. You can see the colors. And yeah. And if you look at the Van stress, because I put a force right there, you can see this color is a little bit less bluish. Okay, so there is kind of stress concentration over there. Of course, the big stresses at the stress concentration around the hole actually masks this right underneath the load. And that's pretty much it. Now, there's something that is asking, it says, what is the displacement at the point C? Now, there's two ways to do this. Let me deactivate this. Look at the translation and double click on it. It says, hey, don't show me the deformed shape right there. So we say, okay. Now, if you get close enough, this is where we are applying the loads, right? And this is where it says 0.383. This is where the force was. See that? And it shows you the actually downward displacement at that location, 0.383. Yeah, that takes care of this problem. We have done some more stuff in the advanced machine tool, and we'll be doing more. But here is one that you could have tried yourself as a homework problem. Good luck.